This is lab 1. The purpose of this lab is to implement logic functions using only CMOS transistors. So I have my NMOS right up here and my PMOS down here. And we're simply taking two inputs, A and B, and putting them through these two different types of transistors. These two types of transistors make up what's called a pull-up and pull-down network. So pull-up network will, once it receives a 1 signal, it'll output a high signal, allowing the light to be on. And the NMOS, just the pull-down network, will output a low signal when it receives a 0. So this specific schematic that's implemented, which is also shown here on the screen, is better known as a NAND logic gate, which means as long as there's at least 1 0, the high signal will stay on. Unfortunately, my board is a little burnt, so I did have to reroute the output to beta, which is on right now. So just to verify that this works, my A and B switches are both 0, so there's at least 1 0. If I turn A on, beta will still stay on. If I turn my B switch on, beta stays on. If I turn them both on, it should turn off. This is part 2 of lab 1, simplifying given expressions and implementing them using only NAND gates. So as you can see my Simulink diagram, I was able to simplify this expression using only NAND gates by applying De Morgan's law multiple times. I was only able to use 4 NAND gates, and this is represented by switches A, B, and C, and this first green LED alpha. So as you can see on the truth table right here on the screen, if I turn all of them on, I should get alpha as 1 or on. When I turn C off, should turn off. When I turn B off, should be off. A and C is on. And when C is the only switch that's on, stays on. Any other combination will keep it turned off. So you can see here, that's A, that's B, and C will turn it on. All right, this is the second expression given that I needed to simplify. As we can see here, the equation states that alpha should turn on if and only if 2 of the switches are on, which means if only 1 switch is on or all of them are off, the light will be off. So I can show that right here. I have A on, the rest is off. I'll turn on B, B off, C. All right, C is on, I'll turn A and C on. The light turns on. Turn B, A, B, C on. Have B, C. If I have just 1 on, then the light turns off. And this is shown in the truth table right here on the screen. As we can see that alpha only turns on when at least 2 1s are present on the truth table.